Avian Frank. We are from our instrumentation branch, and we are here to present our experiential learning project on conversion to Grayscale Image using DSP algorithm. And we'd like to actually, our main motto was to convert the colored image into the grayscale image, basically converting the 8-bit channel to 1-bit channel so that it can be more specific, more specified, and as well as it will be helpful in medical purpose. It will be helpful for them so that they can recognize very clearly. Also, it will reduce the image size. It will be more advanced way. And we are used the two approach, one from the luminous RGB approach and other taking the average of all three and then calculating it to the grayscale. In first approach, here is the algorithm of that approach. Here we have calculated the REG 709 method in which the Y value is actually calculated for the this 0.299, 0.587 and 0.114 is the weighted number for the red, green and blue light, so that is the luminance or the brightness of the according to the human brightness, so that it can calculate these and it can store in the value. There will be a matrix multiplication of every bit size. It will get multiplied and then it will store it into the grayscale. And that will be the calculated using the here's the code. Here we have used the Python code for this. We have first taken the image of that color. We have stored into the red, like it's reading the image, and then there is a dot product using these so that it can get converted into like the red, green and blue thing will be converted into the grayscale. So there is the aspect which is converting the 8-bit image, all the 8-bit image in a one channel. Like there are three multiple channels for all three. So it will convert into the one channel and then it will give the access and it will store it. All the weight keys are used like any other than any other key except this is used. Like we will just put it 0. Nothing will be worked after the multiplication and the addition of that. And then it will display, it will close all the windows and it will display the gray thing. It will minimize the size as well as it will be more helpful for the brightness. Second method is like here you can see our results, like how this is the colored image of all three and then it is converting into a single grayscale, right? And these are the few results of the test. And the second one is, I will show you. Here is the code. So it is actually converting the.
What is the RGB image of this?
Yeah, actually.
This converted one, no? This.
This is our RGB and this is our grayscale conversion. And the second method is our average method and like event.
It uses the average. So what it does is it takes each pixel of the image and then the red, green and blue, it divides it by 3. It takes the average of the 3 values and again stores it into the image. So over here in the code, we first read the image and then we find the first dimensions of the image. And then here what I have done is I have created a separate image, grayscale image, which is like first very just with zeros, makes it only white in color. And then for each pixel, we traverse through 2 for loops and then we calculate the average and store it into the pixel, like the corresponding pixel, the average value in that the other image which we had done with only white thing. So in that each pixel we are storing it, like corresponding pixel we are taking average and storing it in that. So so again we are getting the grayscale image. So this is the second method which we used, which is average, and before we had used the luminance method. So it, just like both of them work very fine in converting from.
Why you are converting RGB to grayscale image?
Okay, there are quite more advantages of converting from RGB to grayscale. That is, when we store RGB, it's like 8 bits of each R, G and B. But when we convert it to grayscale, it is from 0, the values will be varying from 0 to 255 and can be stored in just 8 bits. So we are reducing the 32-bit to 8 bits. So by doing this, we are increasing the processing speed. We are able to increase the processing speed, and even it will reduce the cost because we have to store it in memory. So memory cost will reduce. So
apart from that, minute details will get only in Grayscale Image.
yeah,
So that's why the healthcare field people are using X-ray, MRI, ultrasound.
yes,
They are preparing Grayscale. The minute details, what you are seeing, the hairs and other things, in RGB it is very difficult to
yeah,
get the details.
yes,
So that's why, because 8 bit you take, okay?
Yeah.
LSB is there, MSB is there. You can filter it out further. LSB data, you don't want to you can filter with the MSB only you can form it.
yeah,
Or with LSB only you want to form image, you can form.
yeah.
So that such possibilities further processing you can do.
And yeah, so just I wanted to show the comparison of the two methods. So we can look at the image. So there's a slight one line. So the top one is the using luminance method, and the bottom part is using the average method. So what is happening here is both are converting into grayscale, but in luminance method we are able to even adjust the brightness of the image, which is not possible in average method. So you can see that
To this part, this
Yeah.
will be more brighter.
yeah.
From here onwards, second method. Huh?
Yeah. Yes, sir. So we can even control the brightness. So it is preferred for luminance method more than the average method. So this is
Image contains all data. LSB side, MSB side. We can see the brighter part also is there, darker part also is there, and intermediate shades of grey value also there.
yeah.
For to check in any algorithm, they use that image.
Yeah.
One more cameraman image is there. That also contains all darker part, lighter part, more brighter, much complete brighter part. Okay? With that you can check your algorithm
Yeah.
whether it works fine for the heterogeneous data.
Yes, actually, if, every luminous, the product is there that is different for every colors.
Okay.
So depending on that color, we can actually do that. The brighter and brightest. That's why the luminous is more preferred.
Correct. Because then normally such images are used in healthcare sector. But what doctor finally satisfied with that, to that level, if you make ready and units, you will do treatment better way. Okay. That's that applications. And what made you to select this topic? After so many digital signal processing applications, image processing applications,
Yeah. So
what other applications you have come across?
what happened is like we saw like converting to grayscale. It's just a one line code. We don't know what's happening behind it. Like if you go to just using Python, if you just put CV to convert to grayscale and then just give the RGB to whichever format you want, it will convert it. But we don't know what algorithm, DSP algorithm is working behind the code. So
every tool
yeah.
where it works.
Yeah.
You
So
have
we have
CONV, where that is the file name, function name.
yeah, sir. So what we have done is we have used those algorithms and checked. So here in the first one it's like a dot product which is happening and it's converting using this matrix multiplication. In second one it is updating each of the pixel. It's like traversing from the top to the last pixel, first to last pixel, and it's recalculating the values.
Okay.
So like these are the two DSP algorithms which we have shown to convert from RGB to grayscale.
What else applications you come across with this while searching in the net?
Mostly medical and for image processing, because once you get to grayscale, it's very easy to find the edges of the image, and even like we can improve the quality of the image by doing the contrast, like more contrast, and then we convert it to grayscale. So those are like two applications, but again for processing it's like more easier to process a grayscale image than RGB.
Like sometimes if we
have more
for
details.
other application we need to pass only one channel, like it will be more fast, so we can't give this, like because it has RGB has 8 channels, like 3 different channels of 8-bit. So what we can do, we can actually convert it. It won't affect any information, but it will just convert and it will pass easily, so it can be helpful for other processing
Image
system.
processing main two processes are there: pre-processing and post-processing. Pre-processing means acquired image, we have to make it ready for the next post-processing. If that is only noise corrupted image is there, means with that you can't do directly post-processing. Make it complete ready so that later quantitative analysis, qualitative analysis you can do better.
Yeah.
If for the sake, in the raw acquired image only, we have to make it ready that it may be grayscale image or it may be RGB to grayscale conversion, then removal of noise content. Once you ready, erosion and all that post-processing. Pre-processing means all this removal of noise and making the image look better for further post-processing. Okay, nice. Thank you.
Yes. Thanks.
Thank you, sir.